Imagine your code's data is literally money. Sometimes you want that cash right in your wallet, easy to grab, easy to spend, easy to change up. But other times, you need to lock it away in an impenetrable, heavy steel safe where absolutely no one, not even you by accident, can mess with it. Welcome to this explainer. Today we're exploring the Python tuple, which is basically the ultimate data vault. And then we're going to take that perfectly preserved sequential data and see how we can visualize it on screen using some absolutely beautiful dynamic graphs.
Here's our agenda for today. We're going to start off by meeting the Python tuple, then we'll cover its operations and limitations, and tackle the big question, why do tuples even exist? After that, we'll check out how to convert between lists and tuples, and wrap things up by plotting our data with matplotlib. All right, section 1, let's meet the Python tuple. So at its core, a tuple is a sequence. It's actually very much like a standard Python list. You can iterate through it using a simple for loop, and it stores multiple items for you. But there is one massive foundational difference here. A tuple is an immutable sequence. That word, immutable, it's absolutely crucial. It's the key to this whole concept. It simply means that once a tuple is created in your computer's memory, its contents cannot be changed, like ever. No way. Okay, let's dive into this. A list, as you probably know, is enclosed in square brackets. You can think of those square brackets kind of like an open cardboard box. You can just reach right in, take things out, or toss new things in whenever you want. It's mutable. But a tuple? It uses parentheses, and those parentheses are the heavy closed doors of our steel safe. It's totally immutable. Once you define it, the values inside are completely locked in place. Now, before we go any further, I really have to point out a famous Python gotcha. This thing trips up almost everyone at some point. If you want to create a tuple with just one single element, you can't just put a number inside parentheses. If you write your variable equals parentheses 1 parentheses, Python just thinks you're doing basic math and, well, it creates an integer. To make a single element tuple, you actually must include a trailing comma right before the closing parentheses. So putting a 1 and a comma inside the parentheses, that is the correct way. For sure, don't let that one catch you off guard.
Moving right along, section 2, tuple operations and limitations.
A really good rule of thumb here is that tuples support all the exact same operations as lists, except for the ones that actually change the contents. Makes sense, right? You can still use subscript indexing to retrieve a specific element. You can still use built-in functions like len to see how long it is, or min and max to find the smallest and largest values. You can slice it, search it with the in operator, and even combine them with the plus and asterisk operators. But you absolutely cannot use methods like append, remove, insert, reverse, or sort. Remember, the vault door is totally shut.
Which brings us to section 3. Why do tuples exist?
Okay, let's be real for a second. If tuples are essentially just restrictive, locked-down lists, why do they even exist? Why not just use lists for the whole shebang? Well, the answer comes down to two main things: performance and safety. First up, performance. Because Python knows a tuple will literally never change, it optimizes it behind the scenes. Processing a tuple is actually faster than processing a list, which makes it a fantastic choice when you're handling massive data sets that don't need any modifying. Second is safety. Because you just aren't allowed to alter the contents, you can store your critical data in a tuple and rest easy. You know for a fact that no other line of code in your giant program can accidentally overwrite or corrupt it. It's a real game changer for data integrity. Let's hit section 4, converting lists and tuples. This brilliantly illustrates the flexibility of Python. Honestly, you're never truly stuck. You can use the built-in list function, pass your tuple right into it, and Python will hand you back a brand new, fully mutable list containing those exact same values. Then you can append, sort, or modify that new list all you want. Once you're done tinkering, you simply pass it back through the tuple function to lock it all back up again. It's exactly like temporarily taking your cash out of the safe, doing your business on a workbench, and then locking the results safely back away. All right, time for the visual payoff. Section 5, plotting data with matplotlib. So matplotlib is a separate, two-dimensional charting library that you install via pip. To get started, you use a standard import statement, but instead of typing out matplotlib.pyplot every single time you want to draw something, which gets old fast, we import it as plt. This creates a really handy alias, and it saves us a ton of tedious typing. After that, it's really just a matter of feeding your sequence of x coordinates and y coordinates into a function like plt.plot,
And finally, calling plt.show to actually render the graph in a neat little window on your screen.
Now, what's really interesting about this slide is the actual output of plt.plot. By default, this function creates a standard line graph. The x-axis represents your horizontal layout, and the y-axis is the vertical. The function reads the first element of your x sequence and the first element of your y sequence, plots a point right at that coordinate, and then moves to the next, connecting them with straight lines. It creates this instant, visual representation of the mathematical relationship hidden inside your data.
But hey, what if we want a completely different visual style? Well, we simply change our function call from plt.plot to plt.bar. It's that easy. Instead of mapping a continuous line, our first sequence now represents the x-axis coordinates for the left edge of each bar, and our second sequence represents the proportional height of that bar. It's the exact same underlying logic instantly transformed into a really clean, readable vertical bar chart.
Finally, we have pie charts, which we make using plt.py. Now, unlike lines or bars, a pie chart actually only needs one sequence of data. The function just automatically adds up all the values in your list or tuple, treats that total sum as the quote-unquote whole, and calculates the percentage size for each slice. If you look at the basic version, we see a totally raw pie chart. Kind of basic, right? But on the enhanced version, you can see how powerful it becomes when we pass a second sequence into the labels parameter and use plt.title. Suddenly, those abstract slices of gray become highly readable quarterly sales data. It's night and day.
So, we've seen how to lock our data securely in tuples, how to process it super efficiently, and how to bring it to life visually with matplotlib. It really all comes back to how you choose to structure your information from the very beginning. So, I want to leave you with this final, thought-provoking question for your next coding project. As you're writing out your data structures, if you know for a fact that your data shouldn't change, why isn't it in a tuple? Thanks so much for joining me on this explainer, and happy coding.